Right, so I'm here in my garage recording this video because somebody asked a question on one of my videos that I use for my Economics of the Environment class about the management of non-renewable resources. And the question was basically, how did I produce the graphs that were there in that presentation? Since that presentation wasn't so much about solution methods, it was more about what does the solution say about how different factors influence the way we would manage these resources. So I want to fill in that gap, uh, and that is what this video is for, because somebody asked for it, so I'm perfectly happy to do this. Right, so we're going to start out with the simple version of the problem so that I can show you how this is solved and what I did. Right, so just as a reminder, the setup here, we have 500 units of this resource. This is a non-renewable resource, so when these resources are used, they're used, so 500 is it. Our demand curve is that the quantity is equal to 50 minus the price, so it's a very simple demand curve here with a stop-out price of 50. The price cannot go above that. If the price were to go above 50, people would just stop using this resource entirely and would switch to some other alternative. The cost of extraction, I'm going to keep it the simple case. It's just 0 here. We're going to assume this is a competitive market. So being a competitive market, that means then we don't have the, I guess, immediate direct attempt to try to manipulate the price on the part of the sellers. Right? And that does change their behavior somewhat. But profit maximization is going to lead to then us following Hotelling's rule or Hotelling's principle, which is that the price is going to have to increase by the rate of the discount each period, which in our example, we're going to work it as if it's 10%. So that is what we have here. Now, let me talk about the setup of the Excel program I'm using here, because there very well may be a way to do this analytically, but I'm not going to do that. I'm going to do this numerically using some of the tools we have in Excel. Right, so I set up this spreadsheet this way. Right, so first I have the rate of discount. This is something that then I can fill in. I put in 10% because that's what I used in my presentation. We can also change this to 20%, 5%, whatever we want. We can change this, and I have a formula set up so we'll automatically modify this. Then this total quantity, what I've done, I set up so we can handle up to 50 periods. You can see scrolling down, up to 50 periods is the most that we can handle. All right, so this is taking the total quantity from period 1 all the way through period 50. Right, everything else here, these periods are just the numbers 1 through 50. Price, the first one is what we have to initialize. That's the thing we're trying to figure out, right? So that one I just have 1 in here as an initialization. I could put any number in here. It's it's going to be changed by Excel itself. Right? And then finally, quantity here, this is where I put in the demand curve. Now I did have to put it in a specific way. You can see that I have equals max 50 minus where the price is or 0. This is because otherwise we could end up with negative numbers here, and those negative numbers would create problems so, for the calculations. So I don't want to have negative numbers here. So really that max with comma 0 means that it's not going to allow any negative numbers here. And you could see that when I scrolled down, right? The lowest this went was 0, and then it just kind of stayed at 0. Once the price goes above 50, people stop buying this thing entirely. So things are just, it's not meaningful past that point. All right, so now our last step then is what we have to figure out is what is this initial price? So we need to find an initial price such that this total quantity is going to be the same as the amount of the resource that's available. So here I could just do guess and check, right? Put in 1, put in 2, put in 3, and then narrow it down. That is something you could do, but I'm not going to. Instead, I'm going to use really an automated guess and check method that we have built into Excel. Right, so under the data ribbon at the top, you come over to what if analysis, and choose this thing called goal seek. Right, so what goal seek does, let me double check it. Yes, okay, you can actually see that. Sorry, I had to check my capture software. Then it says set cell. So set cell is where you put the thing you have a goal for. So in my case, I have a goal for having this quantity, right? So I want to set this cell, so E1, to a value of 500, because 500 is the total amount of the resource we have available. By changing cell, the cell that I'm trying to guess to get that number to 500 is that initial price. It says B4. So now what is going to happen is that Excel is going to automatically go through and try to narrow down what the correct price is. Now, a few things about this. Sometimes you can use this to solve any equation. So if you have y equals some function of x, have your x stored somewhere, have your y calculated somewhere. This can be used to to get that calculated value to any value you want, as long as the solution actually exists. Now, if there's more than one solution, then this will not necessarily be able to find all of them. It's only going to find one solution based on the method that it uses to find solutions. But in this case, I'm reasonably confident there's a unique solution, so we're okay. So I'm going to go ahead and click OK here. And there we go. Right, so it doesn't take it very long. It does the guess and check process automatically, and you can see what it created here. So you have the set of prices going from about $8.80, right, rising up to 50 in about 19 periods, right? So then if I want to make this as a graph, as I did in that presentation, I just highlight all this. I'm going to insert this. I'm going to make this as an XY scatter plot. And there you can see they are like, nice and smoothed out like so. And there is the first plot that we had there in that presentation, right, where we can see very clearly the price starts at 850 or so, I believe is what I said. It turns out it's slightly higher than that. It's between 850 and $9. And then we run out of the resource after about 19 periods or so. Now we can, of course, modify this, change the discount to 0.2 or something like that. And there, right, the graph modifies, right? And we can see we run out of the resource after about 10 periods. Then make it 5%, and the resource lasts much longer, long enough that, in fact, it doesn't all fit here. We'd have to change our x-axis to a different value to be able to see when we run out. So it looks like 36, 37 periods, something along those lines. Yeah. So this is just the basic setup. Now remember, there were some other assumptions that I made in different forms. So I'll go ahead and show some of how we can handle that as well. Although here I'm improvising at this point. Oh, wait, I just noticed something. This is not right because this total quantity here, you notice has changed. Okay, right? So what you have to do anytime you change this is something I forgot about. I also need to change, I also need to change some things to get that quantity back. So back to data, right? What if analysis, goal seek again, right? Again, we want to set this equal to 500, right? So it's not automatically going to adjust everything to keep that at 500. You have to keep going back and rechecking that. There we go. So there we go. That's much better. Right, so now the total is 500 again. So we run out after about 24 periods, 24, 25 periods, which I think is what I said in that video. All right. So now let's look at one of the more complicated cases. So I'm going to go ahead and start a new spreadsheet here, and you can see how I build things from the ground up. So I'm going to copy my assumptions here and just have them off to the side. Let's see. I'm zooming in about an extra 30% just because that makes things way easier to read here on YouTube. There we are. So again, 500 units of the resource. Our demand is still going to be that quantity demanded equals 50 minus P, but this time, instead of a competitive market, let's switch it up so that now it's a monopolistic market. Which means then this profit maximization is going to imply not the price is increasing at the rate of discount each period, but rather the marginal revenue is increasing at the rate of discount each period. Now, in a perfectly competitive market like we did before, your marginal revenue and your price are the same. That is not going to be true here for our our monopoly. All right, so let's go ahead and play around with this a little bit so that we can show how we would set this up. So I'm going to need a few columns here. So one, I'm going to want the period again. So there's period. I'm also going to need the price. Not print. Oh, Control B, Control B for price to bold. There we go. I need my marginal revenue, right? And then I also need my quantity. Yes, let's type it all. Although I want to change the order of these. Because my graph, I want to just graph the price and the quantity. So, and then I'm going to make space up here for the discount. Again, I'm going to make that 0.1. And then over here for total quantity. We'll put that formula in a moment. Okay. So, period, I want to be 1 through 50. So I can put in 1, 2, and then just drag that down until we hit 50. And right there will be 50. Okay, so this will allow for up to 50 periods. Okay, my quantity, I can put my formula in here. Or that is, my quantity is equal to 50 minus the price. Now here I do have to put in that formula here with the max. So it's the maximum of 50 minus price or 0. Now marginal revenue is something I'm going to need here. Right. So I need to know the relationship then between marginal revenue and price, really to fill this in, because it's marginal revenue now that is going to be following Hotelling's principle. So let's go ahead. I'm going to go ahead and drag the quantity formula down, and that'll allow me to fill in the total quantity formula, because these are things that are relatively easy to do. There we go. And then marginal revenue. This one, I'm actually going to have it guess the first one, and then the second one is going to be equal to the first one times 1 plus its rate of discount, which I am going to set as an absolute there. Okay, and again, drag it down. So that formula follows through. Make sure it's all B1. It is. Okay, so everything looks good here. All right, so now I need to kind of work backwards. So I have my marginal revenue. So I need to work my way back from marginal revenue. I could go marginal revenue to quantity, then from quantity to price. That's a possibility. Or could go directly from marginal revenue to price. All kinds of ways that I could do this. Right, so I'm going to go ahead and do a few little tweaks here. So first, let's go ahead and put in what my revenue formula would be in terms of quantity, because that's the way I'm used to thinking of it, right? So if my demand is quantity equals 50 minus P, I'm going to rearrange that to an inverse demand curve so that uh, price then I would take out and put 50 minus Q times Q. Okay, so this would be what my revenue formula would be, which then I could distribute that Q through there, which then gives me a marginal revenue formula in terms of quantity of 50 minus 2Q. All you do for that is take the derivative of the revenue with respect to quantity. So that's our marginal revenue is 50 minus 2Q. All right. So now where do I go from here? That's the next step. So I have marginal revenue as a formula. I have price and quantity related to each other as a formula. Well, this is easy. So let's go ahead and, because I can do that inverse demand curve, I'm just gonna make myself a little bit more space here. Right, so inverse demand, I don't know, I'm worried about typing that correctly given that it's gonna be on here saying it's 50 minus Q, not exclamation point, professor. Q, there we go. All right, so we have P equals 50 minus Q, MR equals 50 minus 2Q, right? So then we can use these two to come up with a formula for price connected to marginal revenue. So it's really just a matter of rearranging some things, right? So let's go ahead and do that rearranging. And if we rearrange the marginal revenue formula, we find out that quantity, let's just rearrange a little bit. So 2 quantity equals 50 minus MR, which means Q equals 0.5 times 50 minus MR. So we can take that quantity then and plug that into the other formula, right? So take this formula here, price is 50 minus Q, that means price equals 50 minus 0.5 times 50 minus MR. Now, if I wanted to, I could, of course, simplify this somewhat, but I don't have to. So I'm just going to plug it in that way. So price here is going to equal to 50 minus 0.5 times 50 minus the marginal revenue we find here. There we are. And we can drag this down. All right, so for marginal revenue is 0, the price is going to be 25. Okay, but we do want to have something else in here, right? So let's go ahead and use what if analysis, goal seek. So we want to set this marginal revenue, that first marginal revenue, we want to set rather the total quantity, again, equal to 500 by changing the cell for that first marginal revenue. So it's going to guess and check here until we end up with a total quantity of 500, and I hit OK. Had a little bit more work to get there this time. There were more calculations involved, so it's not particularly surprising. Right. And then I hit OK again to accept this. Okay. And now let's go ahead and graph it out. We can see what it looks like. Insert that scatter plot. Oh, wait a minute. Oh, okay, now I see the problem. I had not apparently selected the period when I decided to make the scatter plot. There we go. Beautiful. Right, so we can see the price, right, certainly starting much higher than in the previous example and going up, again ending right around 50, and the number of periods it lasts now is 30, even with that 0.1 rate of discount, lasts 30 periods as opposed to just, what was it, 19 or something like that. So monopolization does lead to us spreading out the use of this resource over a longer period of time. Okay. And then we also had one more version of this. Right, so let's do one more version. We'll see if this goes any more smoothly than the previous one. All right, so I'm going to go ahead and copy what I have here. Let's start with this. I'm going to have to make some modifications. All right, so this time we have a different formula. So it's not going to be it's no longer a monopolistic market for one. I think that I switched this back to a competitive market, if I remember correctly. Right. And now, rather than Hotelling's rule applying to the price, it's going to apply to the marginal profit, which is price minus marginal cost. So we're going to have to calculate that. That means we also need a formula here for marginal cost. And what I decided to use uh, in my video was a fairly simple one, and that is that it's simply 0.01. Oh, no, it's not. It's the other way around. It's 100 times the quantity that we're extracting this period divided by the reserves remaining. So this is a matter of what percentage of reserves are you trying to extract right now. Okay, so that's what we're looking at here. Right, so a few things that I want to do. Well, one, I need to clear out some of these formulas that are now outdated. Right, so this price formula is no longer going to be accurate. Right. Marginal revenue formula, well, we're not actually using marginal revenue anymore. So we'll delete that. Okay. All right. So remember what we're looking for here is we have price minus marginal. So we need a marginal cost column and a price minus marginal cost column. Okay. So price minus marginal cost is just price minus marginal cost. Although this one, because of the way the formula works, it's going to make more sense for us to start with a guess for the price minus marginal cost for that marginal profit, and then apply Hotelling to that. So I'm going to do that. Right, so here, then this is going to be that one times 1 plus this rate of discount. Again, we're going to need to make that an absolute reference so that doesn't change. Here we are. Good. Then our marginal cost is going to have to follow through. Okay, there's a lot of dependencies here, right? Right, so here's the issue that I'm running into in my mind. Right, oh, we also need reserves remaining. So I'm going to need room here for reserves, which is definitely going to start at 500, and then after that is going to be 500 minus whatever the previous extraction was. So I'm going to go ahead. Oh, here. Nope, I selected too many. I just want the formula to be filled down. Just double clicking here will do that. There we are. Okay, cool. Uh, Next thing we need to do. Okay, so we've got price minus marginal cost here. So we know what that path is going to look like. We're going to start with this as our guess. Then we need to break down price and marginal cost. So here's the issue that I'm running into, right? In that our price, so let's go ahead and kind of work this all out. So we know that marginal cost, so we have P minus MC, it's going to be some number. So rearrange things. P equals 50 minus Q. We know that that's going to be given to us. We also know that MC equals 100 times Q over, I'm just going to use R for the reserves remaining. So then we can use these two formulas with that P minus MC to figure out what Q is going to look like. So P minus MC would just give us 50 minus Q minus 100 times Q divided by R. Okay. Right, so this is going to be another way of looking at that P minus MC. So I'm just going to put it here as a note. So P minus MC is equal to that thing. Okay, so then we can rearrange this and then figure out what our Q is going to be. Right, so doing a little bit of math here. So multiply everything through by R. We've got R times P minus MC equals another R times 50 minus Q minus 100Q. Do some distribution here. R times P minus MC, then we have R, 50R minus QR minus 100. Move that 50R to the other side. So we've got R times P minus MC minus 50R equals, and this would be negative Q times R plus 100. Okay, and then this is enough. This is enough. Right. So what we need to do then to find out what our Q is going to be. So we're going to use a different formula here. We're going to find quantity and then use quantity as the basis for everything else. So this will work perfectly fine. Okay, so our quantity then is going to be equal to the amount of reserves we have times this P minus MC plus 50 times, oh no, minus 50 times the amount of reserves we have. Then we'll take that whole thing, we'll divide it by the amount of reserves plus 100, right? And then we'll put a minus sign in front of it. So this is what the formula would tell us. And then I'm going to go ahead and drag this down. Okay. Now, it looks like we do end up potentially with some negative numbers here. So I do want to, because negative numbers don't make any sense for quantity, I'm going to make this, again, I'll put that max trick in here. All right. And there we are. All good. Okay, then we need our other formulas. So we know our marginal cost is just going to equal 100 times the quantity divided by reserves. And our price we know is going to equal 50 minus the quantity. There, and we can fill those formulas down. Okay. Now that we have all of our formulas in place, and it looks like everything filled well, we can go ahead and use that guess and check method. It looks like we're actually already really close. We're shockingly close. All right. So let's go ahead and data, if analysis, goal seek, set cell, this thing equal to 500 by changing it's P minus MC. And there we are. And that's what we've got. So then again, we can plot this. Insert the chart here, which looks very much like that last chart, where we can see that like we started out actually looking very much like the previous charts, but then as we run out of reserves or run lower on reserves, we're using less and less and less and less of those reserves to the point where it looks like we hit the stop out price and don't actually use up the entire resource in this case, right? So it looks like that is what ends up happening here. Okay. All right, so that's how you can produce these. It's a little bit of algebra combined with using the numerical solution techniques that we have here in Excel, specifically going through that data. So data ribbon, what if analysis, goal seek. It's a great way to try to solve these equations that kind of have some complex structure to them. Another option for doing this would be something called Solver, which you can see we also have available here. That is something you do have to activate on Excel if you have it. It comes with Excel. Uh, Actually, I think it's fair to say it comes with every version of Excel. I'm not as sure about Mac. Might be something you have to go and download this for it, but I know that it is available for it. But that might be something you have to activate. But in any case, right, Solver is a little bit more complicated in what it can handle, and that you can put in more restrictions on it, that kind of thing. But this is how I produce those graphs. So if you're interested in the solution method, it's really this numerical method combining a little bit of algebra with the numerical techniques that we have here in Excel. So I hope that helps.